What's up, guys? In Unit 7, we're going to get into a little bit of introductory calculus. So our focus is going to be just kind of introducing some basic stuff at the beginning of the calculus course and kind of tying in some stuff that we learned this year to help us understand these concepts. So the lesson today is about limits. We actually have learned a little bit about limits this year, but we didn't really call them limits. What we called them is end behavior. So a limit is this. It says as we look at x values that are getting closer and closer to a certain spot, is the function value, which is the y value, headed towards a certain number. So like is your graph, increasing forever, or is it leveling off? Like what's it doing? So we're going to look at this first example, this intuitive definition of a limit, just meaning like what it means mathematically and then graphically. We're looking at a function x squared minus x plus 2. We're going to specifically focus on x values that are getting closer and closer to 2. So you've got two tables here. This table on the left, you're looking at x values that go from 1 and then slowly increase up until we get really close to 2. And then over here, you're looking at x values starting at 3 and going closer and closer to 2. So it's like you're going towards 2, but in both directions. So what we want to know when we're asking a limit question is, what are the y values doing? So as x is getting closer to the value 2, what are the y values getting closer to? So here it looks like the y values are starting to, they're increasing, but then starting to slow down and get pretty close to 4. But let's come the other direction. So let's go from 3 and kind of go backwards to 2. So as x goes closer to 2, the y values again are going closer to 4. So we would then say that we kind of know the limit, okay? Again, I'm not writing it as a limit yet. I'm just explaining the idea. But the idea, here's a graph that goes with it. So this is a parabola that describes our function. Whoops. And in the parabola, we're saying as we get closer to this value of 2 on the x-axis, what are the y values doing? Well, the y values are approaching 4. And so that's the idea of a limit and what a limit is, its purpose is. Okay, so for the last example, we're going to write our limit a certain way. So this is the calculus proper notation for writing a limit. So you would say the limit as x gets closer to 2, okay? So this is like where to focus on the x-axis. F of x is the name of the function. Usually it's going to be the equation. Sometimes it's just written in generics like f of x. And then 4, in this case, was the y value. That's an E. Okay. So then this notation, the way you would read it out loud is you would read it as the limit of f of x as x approaches 2 is 4. Okay, now we could be more specific because we did know the equation that modeled our specific example was x squared minus x plus 2. So in place of f of x, we would actually make this more proper by putting the function in its place. So we would say the limit of x squared minus x plus 2 as x approaches 2 is 4. Okay, so here's an example I think that you're going to find helpful. We have this function, and we're going to answer some questions about it in a calculus way and a pre-calculus way. So on the left is the pre-calculus way, what we would have used to describe the function in prior units. So this is saying as x approaches negative infinity, the graph of f of x approaches what? So it's asking you to read the graph and look at what's happening as x goes to negative infinity, which is like go to the left side of the graph. So the left side of the graph appears to be leveling out, and it is leveling out right at the asymptote, which is at 3. So that's how we would say that in pre-calculus. Now that we know a little bit about limits, we're going to write it the calculus way. And so we're going to say the limit as x approaches negative infinity. And this function is called f of x. We don't know the equation for it, so we'll just say f of x. What does it do? It levels out at 3. So that would be the calculus notation. As x goes to infinity, the graph does what? So infinity would be the right side. And we're saying on the right side of the graph, what are the y values doing? The y values are also leveling off at this asymptote, so that would also be 3. And then the calculus way would look a lot like the one above it, except we would say as x goes to infinity, it equals 3. Okay. As x goes to negative 3 from the left. Okay, from the left. So where is negative 3? Negative 3 is right here. So from the left means find the left side of the graph and kind of follow it, only coming from the left side of negative 3, and tell what the graph is doing. So if I'm following the graph, I'm getting closer and closer to negative 3 on the x-axis. My graph is going up. So it is going up, and we would call that infinity. Okay, we actually do have a special notation to describe which direction you're approaching a value from. So this question said to approach from the left. We would say approach negative 3 with a little negative, kind of like an exponent, to describe the direction. And it's a negative because numbers on the left side of a graph are negative. So you put a little negative 3 and then put a little negative to say from the left. And then what did we say it was? Infinity. It's infinity. Okay, let's do the same thing, but from the right side. So from the right side of negative 3 would be this way. And this is obviously going down forever the closer we get to negative 3. And so that would be negative infinity. Okay, so we're going to write the limit as x approaches not just negative 3, but negative 3 from the right is going to be a little plus. And it's like an exponent. And that was negative infinity. Okay, 2 more. As x approaches 3 from the left, the graph of f of x does what? So as I'm approaching this spot from the left would be this way. I'm getting closer and closer to, I don't know, what do you think? 1.5 maybe? 1.5 sound okay? There's a hole in the graph, which is weird, but you know what? When you're doing a limit, it doesn't matter if there's a hole in the graph, because limits are asking what your graph is approaching, not what is your graph equal to at that point. So it's just like, what are you getting closer to, but not like, doesn't matter if there's a hole in the graph or not. All right, x approaches 3 from the left would be 3 with a little negative, and that is equal to 1.5. Last one, 3 from the right side. So right side, go closer to 3, also going to be 1.5-ish. And then the calculus way would be the limit as x approaches 3 from the right would be a little plus of f of x equals 1.5. Okay, so this is a summary of what we kind of just discussed. So there are different types of limits. You could just do a regular limit saying what you're approaching from both directions, or you could have a left-hand limit and a right-hand limit. So a left-hand limit looks like this with a little negative as kind of an exponent, and that says to go approach a value from the left side. And then a right-hand limit is a little plus sign, and that means to approach a value from the right side. If there's no little plus or minus, it means to approach the value from both directions at the same time. All right, so let's do some examples. It says just find your limits. Okay, so your first one is x is approaching 2 negative, which means from the left. So you're approaching the value 2, so follow your graph and get closer to 2, but come from the left side of that. So it looks like we're getting closer and closer to 4. Remember, this hole in the graph, it doesn't matter. It's just what are you getting closer to as you climb this graph, not what is the dot equal to. Okay, so I'm getting closer and closer to y values that are equal to 4. From the right side, that little plus means from the right side. So from the right side, I'm also approaching 4. Okay, and then let's skip C for a second. Let's go to D. So D says just approach 2. It doesn't have a directional component. So you would be coming in from both directions and say if I come in from this direction and I come in for this direction, do they meet up? They do meet up at 4. So your limit would be 4. So then what is this asking? What does it mean? What's f of 2? F of 2 just means that when x is 2, what is y? It doesn't have anything to do with what you're approaching. It's just asking you like an ordered pair. So like if x is 2, what is the y value of the ordered pair? And that would be like what the dot is at. So that would be -2. Okay, we're going to see some different things happening here. So the limit as x approaches 1 from the left. So here's 1. So when I follow 1, the curve, as I get closer and closer to 1 on the x, and it's leading me to 3. But look what happens. When I do 1 from the right side, I get a different answer. I get 1. So that means, I'm going to skip G for a second. That means when I go down to do the limit without a directional component, it means come from both directions. Well, if I come from the right side, I end up at 1. If I come from the left side, I end up at 3. Since these 2 points are not meeting up in the same location, we're going to say that the limit does not exist. You could also call this D and E for does not exist. It basically just means that like my limit doesn't meet up in the same spot, so I can't say that my function is approaching anything if I'm looking at it coming from both directions. All right, last question, what's f of 1? So that means when x is 1, what's the y value? So you're looking for the filled in circle here, okay? So when x is 1, the y value looks like it's also 1. Okay. X approaches 2 from the left. So 2 from the left, here's 2. From the left, we're going to infinity. 2 from the right, we're also going to infinity. The limit from both directions, well, both directions, you're going to infinity in both directions, so infinity again. And then what's f of 2? Well, if there's an asymptote here, is there ever going to be an ordered pair on the asymptote? No, there's not, because an asymptote is like an imaginary line that your graph is never going to touch. So f of 2 does not exist. All right, I think I just have like 2 more examples. So just some more kind of throwing it all together for you with a more complicated graph. So the first question is, what is the limit as x approaches 3? No directional component, so come from both sides. So here's 3. Left side and right side both meet up at 1. The y value is 1. The limit as x approaches 1 from the left. So here's 1. Here's 1. Come from the left and you're at -3. X approaches -2. No directional component. So come from both sides. And you're at a y value of -2. Okay, here's another one. Those weird other questions, not limits, but what's f of -2? Is that different than the last question? Yes, because this is asking for an ordered pair. So where is the dot? Well, -2 is all the way up here at 3. As x goes to infinity, so that would be like follow the right side of your graph. Well, this line looks like it's going to keep going up forever, so I would say infinity.